Hello and welcome to my channel. Today we're going to do an exercise about changes in acceleration. So before we start, I actually recommend to download this PDF which you'll find in the description of this video to follow what I'm doing. It might be easier for you to follow what I'm doing. So now that we can start, I'll say we can start reading the problem. So a man of a mass 80 kilograms stands on a weighing scale in a lift. If the scale reads in newtons, find the reading on it when the lift is at rest. Okay, so let's do part 1 first. Before we start, I have to say these two things, okay? So we have this formula here, which is F is equal to ma. Okay, so force is measured in newtons. It's equal to the mass measured in kilograms by the acceleration measured in meters per second square. Acceleration normally means gravity, but you might find exercises in which they will say something different, which will be the acceleration of a car. But anyway, I have to explain another thing as well, is that the mass of a person, okay, let's say the mass of a person, which is 80 kilograms, will always be the same no matter where he is or the acceleration he's experiencing, but the force or the newtons, the mass in newtons will be different depending on the gravity, okay? So the newtons depends on gravity. Okay, that's something you should know, okay? So I'll explain you why, okay? So let's say the gravity in Mars is 4.6 meters per second square, which I'm not sure, but let's just say that, okay? Then the mass of this man would be force is equal to 80 kilograms by 4.6 meters per second square. So this would be different, okay, that this result will be, let me just get a calculator, so it would be 8 by 4. It would be 368 newtons, okay, and this is on Mars. But their newtons, the weight of newtons on Earth would be 80 multiplied by 9.8, which is the acceleration due to gravity on Earth, which would be 9.8 multiplied by 80, 784 newtons, okay? So as you can see, the weight in newtons depends on the gravity, okay? But the mass is always going to be the same. So that's the first thing you should know. Second of all, you should also know that gravity changes depends on the movement of the person, of the object, okay? So let's say this person on the elevator, he's on a weighing scale, okay? Just a little thing here. And let's say the elevator isn't moving, okay, while the mass, the force of this person, if the elevator is at rest, the force, the gravity will be the same no matter where he is. If he's not moving or accelerating, then his weight in newtons is going to be the exact same. So as we did before, mass is equal to 80 by the gravity, which is 784 newtons, excuse me. So that's the first part done, okay? But what happens if the elevator, okay, so let's go to part 2. Let's say the elevator is moving upwards at a steady speed of 3 meters per second square. And keep in mind, this is speed, okay, steady speed, no acceleration. Okay, well, if the elevator is speeding up, it's not speeding up, it's moving upwards at a steady speed, no matter how quick it goes. So if it's going at 800 meters per second square, which is really, really quick, unless he won't experience any kind of change in gravity, and he wouldn't even notice if there wasn't any kind of shaking or sound or windows. He wouldn't know he was moving, okay? He wouldn't notice anything. So sometimes you might feel like the elevator is not moving if it's really quiet, and you only feel the difference when it's accelerating upwards or downwards, okay? So that's when you actually feel the difference. If not, you wouldn't actually feel the difference unless it's making a sound, or it's not actually just moving, it's just accelerating up and then accelerating down, okay? So the gravity he's gonna experience will be the exact same. So no matter the speed he's going at, the acceleration will be the same. So the result for this question will be the exact same one as this one because the gravity is the exact same. Okay, but what happens when as the lift is accelerating upwards? Okay, at 4 meters per second square, which is in part 3. Let's say the elevator is spinning upwards, so the acceleration is going to be 4 meters per second square. Well, this is actually different, okay? Because the gravity this man is going to experience is going to be 9.8 meters per second square, which is gravity, plus 4 meters per second square. But you might ask, why is it 4? It is 4 because the elevator is doing extra work to bring the elevator up, okay? To bring the weight of this person up. So this person is going to experience the gravity of the actual gravity plus the 4 meters per second square. Okay, so you might think it doesn't really make sense because the errors would cancel each other out, but the man is going to experience a lot more weight. Well, he wouldn't actually experience it, but if you put a scale underneath you when you're going upwards in an elevator, you will feel like your weight is gonna go up. Okay, so so the gravity of this man will experience when he's accelerating upwards at 4 meters per second square will be 13.8 meters per second square. So that'd be the gravity he is experiencing at that moment, okay, when he's accelerating upwards at 4 meters per second square. So now that we know that his gravity, we know that F is equal to ma. So the mass of this man is 80 and the gravity is 13.8. So the result of this would be 1,104 newtons. So as you can see, his weight in newtons is going to be different because, as we said before, the mass of a person doesn't change no matter where he is, okay? But what happens, that's the answer for question 3. What happens if the elevator is accelerating downwards at 9.8 meters per second square? Okay, well, for this, I'm going to put up an example, okay? You're actually going to understand it better. So let's say the elevator is going at 9.8 meters per second square. So this is the same as gravity. Well, you might have seen videos of people in planes where they are experiencing zero gravity. So what's actually happening is that the plane is going downwards. Okay, I know it's not a great plane, but okay. So the plane is going downwards at the exact same speed as accelerating at the exact same acceleration of the acceleration due to gravity. So it's going downwards at 9.8 meters per second square. So the people inside the plane feel like they're actually feeling no gravity at all. Okay, so it's just experiencing no gravity, free fall gravity. Okay, so this is what's actually happening. It's happening. So the plane goes up as much as they can, and they just kind of like let go down. So that's what they're actually experiencing. Okay, so now that you know that, if the elevator is going down at the exact same acceleration due to gravity, okay, then we have that the force is equal to ma. The gravity this man is experiencing is 9.8 meters per second square minus 9.8 meters per second square, which means 0. So if the acceleration is 0, if the mass of the person is the exact same, but the acceleration is equal to 0. So any number multiplied by 0 gives 0. So 0. So his weight is going to be 0 newtons. So the weight is not going to move. Okay, so that's the main thing about these exercises, okay, just understanding this, okay. So I was taking notes about this and try to do different exercises and trying to find the logic of it, okay. So my main advice I would give you is try to imagine yourself in an elevator, and whenever the elevator starts going up, accelerating up, you feel like the elevator is pushing you up, okay. So because the elevator is pushing you up, you're going to experience more gravity, okay? So that's the main advice or trick I will give you. Or think about the plane when it's going down at the same speed as the same acceleration of gravity. So you will feel like this is how these videos are recorded on YouTube. So that's all for this time. If you want to, I will upload this PDF onto Dropbox, and I will put the link in the description so you can download it if you wish. Okay, thank you for watching.